Now we're starting a new topic, and this is the topic of number systems. We actually very quickly looked at this earlier in the year, so you'll remember a lot of it. It's about the different types of numbers that we have. And I'm going to start by drawing a set. Okay, the set of all types of numbers that we could possibly have is called the real numbers, and it's represented by an R with an extra line in it. The name of a set always goes on the outside of the circle, not on the inside. Okay, some people sometimes get confused with that. And that's all possible numbers. We'll write down a definition of it in a minute, but I just want to show you how they stack together. Inside the real numbers, there's a subset that we call the rational numbers. Now, the rational numbers are not represented with an R because we already used that for the real numbers. Sorry, my circle got a little bit out of hand there. The rational numbers are represented by the letter Q, which is Q for quotient, and they're every number that can be written as a fraction. Every rational number is also a real number because it's inside of it. Inside the rational numbers then, we have a set of what we call the integers, and the integers are represented by the letter Z. And those are all whole numbers, whether they are positive or negative. Every integer can be written as a fraction. Every fraction can be written as a decimal. That's the easiest way to think of them. Decimals, fractions, whole numbers, positive and negative. So then the smallest set that we have inside the integers is the natural numbers. Be careful when this is at an angle, they can look like each other. And the natural numbers are whole positive numbers only. So let's put some examples in here. If I have a whole number and it's positive, so for example, the number 3 would be in here. The number 18 would be in here. If I have a whole number and it's negative, it's going to be out here, like -2. And actually, 0 would be here as well. So 0 is not a natural number because it's not positive. It's not negative either, but it's not positive. Outside of that, then we have fractions, like 2/3, or even negative fractions, -7/18. And then outside of that, we have numbers which are decimals that can't be written as fractions. So for example, 0.33 would not go in here. It would actually go in here because 0.33 can be written as a fraction. I can write it as 33/100. So I wouldn't put it in this section out here. What does go in this section out here then? Decimal numbers that can't be written as fractions. What kind of decimal numbers can't be written as fractions? We have a special name for them as well. Well, for example, pi. Now you'll tell me, but we do write pi as a fraction. Well, we do, but that's only an approximation of it. 22/7 is not the value of pi, it's just close to it. These types of numbers, the square root of 2, things added on to those types of numbers, and we have names for those, like the square root of 3 plus 1. This section out here is not the real numbers. The whole thing is the real numbers. This section out here, the real numbers that can't be written as fractions, doesn't have a symbol of its own, but from sets, we know that this can be written as the real numbers take away the rational numbers. The real numbers take away the rational numbers. And we have a special name for that. We call them the irrational numbers. So now, let's write down some definitions of these different sets of numbers. I'm going to start with the smallest one first. We've written this before, so I'm going to go quite speedily through it. The first set that we want to deal with is n, and that is the natural numbers. The definition of the natural numbers is all whole positive numbers. For example, 1, 2, 3, etc. The next biggest then is the integers. And the integers are whole numbers that are also positive or negative. All whole numbers. Positive and negative. For example, -2, -1, 0, and yes, all of these guys as well. So the natural numbers are a subset of the integers. After that, as we talked about, we have the rational numbers. You need to know the definition of rational numbers. You can be asked. So these are all numbers that can be written as a fraction. Can be written as a fraction of integers. And it's really important that you include that. Not just that they can be written as a fraction, but that they can be written as a fraction of integers. That means a whole number on top and a whole number on the bottom. Okay? So you need to be able to write them. As we mentioned above, you don't have to write it as a fraction. There are lots of numbers that we don't write as a fraction. .45, which we can write as 45 out of 100, and we can simplify that. 2/3, -18, -5, because we can write that as -5 over 1. So what you can see there is that every integer is also a rational number, which means, of course, every natural number is also a rational number. And then the final set that we have is the real numbers. And these are all numbers. All real numbers. Decimals, fractions, integers, etc. So, for example, whole numbers are real numbers. 3 is a real number. 2/3 is also a real number. But here are some real numbers that aren't any of the other 3. The square root of 17 minus 2. 5 multiplied by the square root of 3. We have a special name for some of these as well. But finally, we want to talk about this set that we wrote up here. Decimal numbers that can't be written as fractions. And this set doesn't have a letter of its own. It's R less Q, and we call them the irrational numbers. So the irrational numbers are all real numbers that can't be written as a fraction of integers. Okay, and that's the definition that we need there for the irrational numbers. So you need to know all of those definitions, and this diagram is a handy way of remembering how they fit together as well. How do you know if a decimal number can be written as a fraction or not? If you see a decimal number, how do you know if a decimal can be written as a fraction? Well, there's a very easy way of checking. A decimal is rational. Say it's an element of Q if one of the following two things is true. Either it terminates. What does that mean? That means it stops after some decimal places. For example, 0.45, it stops. Or 0.108925. It's long, but it does stop. Those guys will definitely be able to be written as fractions, okay? Or the other possibility is it has a repeating pattern. So, for example, we know that when we write a third as a decimal, it doesn't stop, it doesn't terminate, it just goes on and on and on forever, but we have a repeating pattern. So because I have a repeating pattern, I know that this, even though it doesn't terminate, can be written as a fraction. Fraction in this case being a third. So if I see a decimal like this, for example, let's see, to get a good example, 0.2777. Okay, it won't always be the same number, but eventually you just see a repeating pattern. We don't know what fraction it is, but we know that this is a rational number. Must be. Okay? So, therefore we can say irrational numbers don't terminate. So when you write them as decimals, they don't terminate. And they don't repeat either. They have no repeating pattern. And the example that we have there would be pi. So if we were to write pi as a decimal, we can see it in our calculator. Now the calculator runs out of space, but you can see the values there. There's no pattern. What you can't tell is that it doesn't stop there. Pi continues forever and has no pattern that has ever been found. In fact, it's been proven that it will never have a pattern. That's fairly complicated maths, 2, 6, 5, 4. At this point now, computers have calculated pi to millions of decimal places. So it doesn't terminate and it doesn't repeat, which is why we can say that pi is not a rational number. So tomorrow we're going to start learning about a specific type of irrational number that we need to be able to work with called surds. For the moment, I just want you tonight to study your probability in preparation for next week's test and learn your definitions from number systems, which we have seen before, but it's very, very important that you know as well before we do the next step. Okay, thank you very much.